Let's talk about disaccharides. So moving on from monosaccharides, now we're building on to disaccharides. So basically, what are disaccharides? Now we know that when you have two monosaccharide units, when they are joined together, let's say this is one monosaccharide unit plus another one. When you join them, you're going to make what we call a disaccharide. Okay, so that's what a disaccharide is. Now, these monosaccharides, you know that monosaccharides are just simple sugars. So when they are combined, this reaction where you have one monosaccharide, let me say this is one monosaccharide plus another monosaccharide, then they give you a disaccharide. This reaction is called a condensation reaction. Now, it's called a condensation reaction because a molecule of water is released. Okay, so this is very important for us to know. Okay, so how is the molecule of water then released? So what we should understand is that let's say the first monosaccharide has a hydrogen. Okay, and then the other monosaccharide, it has an OH group. Okay, now these are going to combine and they are going to release a molecule of water. That's how come it's a condensation reaction. Now basically there are about three common disaccharides that you're supposed to understand. The first one is maltose. The second one is sucrose. And the third one is lactose. Now basically these are the common three. Okay, of course there might be other variations, but the common three that you're supposed to understand are these maltose, sucrose, and lactose. Now maltose, it is made from two glucose molecules. Now these are two alpha glucose molecules. Okay, that is very important. So what this means is that you have glucose plus glucose. Okay, so glue plus glue will form maltose. Then on the other hand, sucrose itself, it is going to come from one alpha glucose molecule plus a fructose molecule. Okay, now these ones that we are mentioning, glucose, fructose, these are monosaccharides. Okay, so then a lactose as a disaccharide is going to be made from alpha glucose plus galactose. Basically these are the combinations. Now why are we emphasizing on the alpha, probably the beta also? We are emphasizing on these ones because they show the properties of a molecule. So alpha and beta, these ones come due to the position of the OH on their numeric carbon. So let's say if this is this is a sugar molecule, the carbon at number 1, okay, this is a carbon that reacted forming this cyclic chain. Okay, now it reacted with either the aldehyde group or the ketone group that was on top. Now what you should understand is that if your OH is up, it means something. Then if it is up, this is called it's beta. Okay, and this carbon is called the anomeric carbon. Now if your OH is down, this is called alpha. Okay, basically that's the difference. So if we say it is alpha glucose, it means this glucose, its OH is at position number 1 and it's reacting with another molecule on the other side. That's why I'm specifying that it's an alpha glucose. However, if the OH was on top, it would have been a beta glucose. But you're going to realize that in nature, naturally, you're going to find that alpha glucose is in abundance. So that is very important for us to know. Now, what are the linkages? So let's start with maltose. It is very important to know the linkages, how these molecules they form a link, because basically how it forms a link will also be related to whether it's going to be a reducing sugar or a non-reducing sugar. So basically, let me put a linkage here, and maybe let me put some sources. Where are you going to get some of these disaccharides? So maltose, we said it's made from 2 glucose molecules. So this one is going to be made from alpha 1,4. It's called the 1,4 linkage. 1,4. Okay. What this means is that at position number 1, we said if it's alpha, meaning your OH is a down, right? Okay. So now the glucose, the hydrogen at position number 1 is going to react with the hydroxide at position number 4, basically to form that water. So basically that is 1,4 or 1 to 4. Okay. Now the sources of maltose, mostly you're going to find it in cereals and malt. Okay, cereal. Okay, and usually mostly germinating seeds. Okay, that is very important for us to understand. Then if we're going to talk about lactose itself, what is the linkage? So the linkage for a lactose is beta 1,4. Okay, because the position of the OH is what? It is on top, right? It's on top. Yes, like that. So if the OH is on top and it's the one that you're reacting with, basically that. Or if maybe OH is also this side, as long as it's on top, that becomes a beta. But mostly we focus on the anomeric carbon. Okay, that is beta 1,4. It's very important. Mostly lactose, we're going to get it, the source mostly is milk. Okay, then sucrose. Now sucrose is a bit different. It's going to be made from alpha and beta 1,2 linkage. Okay, so now this is very important because if you're going to look at sucrose itself, it happens to be one of those sugars which is not a reducing sugar, okay, because of the beta here. Okay, now you're able to realize that we said sucrose is made from glucose and fructose. If you look at the fructose, the way it is, I think it's one of those sugars that has a ketone, okay, something like that. So we find that because of that arrangement, you're able to have the alpha and the beta. Basically that doesn't make this molecule to be reducing sugar. Then mostly we're going to find your sucrose. Your sucrose, you're going to find it in foods like sugar cane. Okay, you can find it in sorghum, carrots, sugar beet, to mention but a few. Okay, so that is very important for us to know. Now let's just talk a bit about maltose. Now if you're going to talk about maltose, humans themselves are unable to metabolize maltose, or let's say most of these disaccharides. Okay, so you find that you've eaten, let me say a cereal, then you find that is it contains a lot of maltose in there. So you find that you've consumed it direct from the diet, but now these molecules are too large for them to pass through the cell membrane. If you see the cell membrane, it will be very hard. Let's say this is the cereal that you've been eating. Okay, now these ones, for them to pass through the cell membrane of the interstitial wall in let's say in your stomach, they are very large enough. So these ones, first they need to be broken down by hydrolysis into simple molecules. And we know that when you break down your maltose, or let's say your disaccharides, you're going to get your monosaccharides, right? So that is very important for us to know. Now, which enzyme, if you are getting maltose, which enzyme is going to react on maltose? Carbohydrates, they end in OSE or OS. So basically, if I'm going to talk about the enzyme, an enzyme will be called the maltase. So what this says is that enzymes in terms of carbohydrates are going to be ending in ASE. Okay, so that is very important for us to know as far as maltose is concerned. Now further, we talked about lactose. Now what about lactose? So the lactose itself, we said, is only found in milk. Okay, now this lactose, it has different concentration, yes, in different organisms here and there, but what should we know? What we need to know is that lactose is a reducing sugar. Okay, it's able to reduce those copper 2 sulfate ions. Okay, then we've said it has a glycosidic link of beta 1,4. Okay, now lactose itself, because it's found in milk, you're able to now conclude that it is an important infant food component because these children need it. Okay, now of course in advanced, when you go advanced, you're going to realize that lactose is also used in the production of penicillin. Okay, basically that. Now there's what we call lactose intolerance. So what about lactose intolerance? So mostly you're talking about the deficiency of lactose. Now if you have a deficiency of lactose in your body, you're going to, there's a genetic condition that we call by that name. Okay, if there is deficiency of lactose. Okay, no, so there's this enzyme that is responsible for breaking down lactose. Now we've said all the enzymes, when it comes to carbohydrates, they are going to end in ASE. So that enzyme will be called lactase. Now some people don't have this enzyme. Okay, so that is a genetic condition. That genetic condition is called galactosemia. Okay, so that is very important. And we've said lactose is made from lactose is made from glucose and galactose. So this literally makes sense. So there is an absence of an enzyme that is needed to convert your galactose to glucose. That's why it's called galactosemia. And that. Okay, so now you're going to realize that certain bacteria can metabolize lactose, and when they metabolize lactose, they're able to form what we call lactic acid. Okay, now lactic acid will be one of the products that is going to be formed. So now if a bacteria converts this lactose to lactic acid, when it comes to milk, as far as food chemistry is concerned, it is going to be the one that is going to be responsible for the souring of milk. Okay, souring of milk. So basically that. So it is very important. Now in people with lactose intolerance, some of the what you're going to realize is that since you don't have that enzyme that converts your galactose to glucose. So you find that yes, they've taken their, let's say this is the gut. Okay, let's say this is the lactose or the milk that you're just from drinking. Now most of this lactose is not going to be hydrolyzed, it's not going to be broken down. Okay, so now what is going to happen is that your colon, water is going to follow to where your glucose, your lactose is. The process of osmosis. Water is moving from a high concentration to a low concentration. Okay, why is that? Because you're trying to balance up. It always tries to balance up. Okay, so nature always tries to balance up. So what water has to go there so that it balances up, it buffers the system. Now when it goes there, and this is the gut, okay, so, and that is the alimentary canal in simpler terms, so it will pass into the colon. Now when water has been drawn now from the interstitial fluid of the lumen by osmosis, so water is going to build up in the lumen, okay, of the alimentary canal. So now the build up of this water, and as it is building up, there's going to be some bacterial decay products that are going to be formed. So basically, as the bacteria is decaying, you're going to have some abdominal distension, okay, abdominal distensions. You're going to have some cramps. Now the common one that you're going to see is diarrhea. Okay, diarrhea. Now does that mean that these people are supposed to do something? Yes, it's supposed to do something for it to disappear. So for these symptoms to disappear, it's just that milk has to just be excluded from the diet from those who are lactose intolerant. Okay, or maybe they can be taking milk but sparingly, okay, in little, or let me say controlled amounts. However, due to advances in technology, people have come up with alternatives. Okay, so many food stores now, they carry some brands of milk that have pre-treated, so pre-treated milk. Okay, excuse, so pre-treated milk with that enzyme that we talked about. So they make sure that this milk is passed through that enzyme. The enzyme breaks it down already so that you can at least have some milk in your body. So that is very, very important for us to understand. Now basically, let's talk about the last common monosaccharide that we talked about, and we're not going to spend a lot of time here. Sucrose. Now we've said mostly you're going to get it from sugar cane, sugar beet. We've said sucrose is going to be made from glucose and fructose. Okay, so yeah, that is that. Now on sucrose, what I want us to understand is that yes, it is a disaccharide. If you want to break it down to glucose and fructose again, you're going to need an enzyme. We said all these enzymes are ending in ASE, so this is called sucrase. However, in other literature, they call it invertase. Now, sucrose itself is a non of those disaccharides. It's a non-reducing sugar. Okay, so the anomeric carbon of group numbers 1 at position number 1 of the of glucose, and then on fructose at C2, they are the ones that are going to be involved in forming this linkage. And we said when this linkage is forming, because this is a glucose, let me use a different color. So this is glucose, this is fructose. So now the positions is that this one is C1, this one is C2. Glucose is alpha, fructose is beta. Okay, the positions. So because of that linkage, you are going to have a linkage alpha, comma, beta, which position 1 and 2. Okay, basically that. Now because you've got this, it will be very hard for it to be reduced, okay, to a simple sugar. So it's a non-reducing sugar. So that is very important for us to know, and this is what we're going to end for today, talking about disaccharides. Thank you.